All right. So when I'm multiplying polynomials, to me, it's all about dimensions. And when I'm talking about dimensions, I mean, what is this polynomial? What is this expression? This is one term, and this is two terms. So this would be a 1 by 2. If you look here, this is two terms, and two terms are two groups, 2 by 2. If you look at this one, there are 1, 2, 3, 1, 2, 3. This would be a 3 by 3. Okay? So there are a couple different ways to do this problem. One way is to do the rainbow method. And I'm okay with the rainbow method. But what I don't like about it is silly mistakes happen. So what I'm going to do instead is make a 1 by 2 box. I don't care which way you do it. Show your work and get the right answer. So the first thing goes here, and then I put that first term there and the second term there. What I like about this is it focuses my eye on just this box. Notice how I'm covering it up. So I'm going to go -3 times 4 is -12. Remember, when I'm multiplying exponents, I really add. So 2 plus 1 is 3. Now what I'm going to do is do the same thing. Notice how I cover it. But now my eye focuses here on -3x squared and +5. -3 times 5 is -15, and it's just x squared. The only reason this one is more annoying is just because you need to rewrite the answer. I think some of you are going to like the rainbow method for some of them, and some of you will like the box for the other. I don't care. Get the right answer. Let's try the next one. If you look over here, there's one group by 1, 2, 3. So I'm going to do a 1 by 3 box. I know it's kind of obnoxious, but this way I have room. And when I have room, I get a little bit more confident. Notice how I put a 1 there. It just makes it easier for my sanity. And I'm going to multiply. 6 times -1 is -6. 1x and 7x make 8x's. Now I'm going to cover this up. Oops, that didn't do a good job. Let me do the glue stick. And I'm going to do the next one. So 6 times -6 is -36. I have 1x and 2x. I have 3 x's. Now I'm going to cover those two, and I'm going to focus here. 6 times 4 is 24. And then I have 1x. So that's a positive 24. So my answer is -6x to the 8th minus 36x cubed plus 24x. If you want to check this in the calculator, you'll take the question, set it equal to the answer, or in Desmos, you can graph this and make sure they're exactly the same. Let's go to the next one. 2 by 2. I think a lot of you are familiar with this. So there's 2 this way, 2 this way. It doesn't matter if you put x plus 3 here or x plus 3 here. I'll just put it here because I feel like it. And I multiply. X times x is x squared. X times negative is -7x. 3 times x is 3x. And 3 times -7, biggest mistake is people add. Now, 95% of the time, the diagonals will be the same. And that's what I like about it. And when the diagonals are the same, you just add them. So I keep the first guy, add the center, and then do the last. And there's my answer. You can check this by factoring. 2 numbers that multiply to get 21 and add to get -4. That works. Okay. The dimensions of this, 1, 2, 1, 2, 3, 2 by 3. And again, let me point out here, you could have done the rainbow method on the previous one. Give this guy to this guy, this guy to this guy, this guy to this guy, this guy to this guy. And some of you might do that. You might have done it here. This guy, this guy, this guy, whatever. But I do feel like it gets a little bit more difficult when you do 3. Because then what you're going to do is give this one to this one, 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 this one to this one. And then when you simplify it, it goes horizontally. It kind of makes a mess, at least for me. So I'll keep the box. And I'll focus on the first row. X times x squared, because there's a 1 there, is x cubed. X times 9x is 9x squared. X times -5 is -5x. I want you to notice a pattern here. X cubed, x squared, and then x. That'll work 95% of the time. Then I look here, and now I'm not looking at that top row anymore. I'm looking at the bottom row. So -2 times x squared is -2x squared. -2 times 9x, -18x. A negative times a negative is a positive. X squared, x, and then a number. It follows the pattern. And remember how I said before the diagonals 95% of the time will be the same? Those are the same. Look at, there's other diagonals. Those are the same. That's the convenient thing about the box. It sets it up for a pattern. You would still end up writing all of this down horizontally if you did the rainbow method. It's just more difficult to see the things that are the same. So x cubed, 9 minus 2 is 7x squared, negative 18, negative 5, negative 23x, and plus 10. So this is a polynomial, degree 3. And there are 4 terms. Let's go to the next one, 3 by 3. Let me point out again, you can do this one to this one, 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 this one to this one. Or just make a 3 by 3 box. And if you feel like you don't have enough space, well, you can always use scratch paper. So 4x squared minus 3x minus 7, negative 1x squared plus 5x minus 3. Remember how I talked about patterns and I said this is x cubed, x squared, and then x? It worked because this went x squared, x, and then a number. This went x and a number. So since this goes x squared, x, and a number, x squared, x, and a number, I know that the diagonals will match up. Okay? So let's multiply. Negative 4, 2x and 2x is 4, plus 20x cubed minus 12x squared, x to the 4th, x cubed, x squared. Now let's do this one. A negative times a negative is a positive 3, x cubed. So 4, 3, 2, this is going to go 3, 2, 1. This is going to go 2, 1, nothing. You'll see what I mean. Negative 15x squared, positive 9x. Now take care of the bottom. 7x squared minus 35x plus 21. This time the diagonals are still the same. The first one stays as it is. And let's look at the second one. So the cubes are together. And I liked putting the pluses there because it makes it easier for me to add it in my head. Now if you look, all 3 of these are the same. So 7 minus 15 is negative 8, minus 12 is negative 20x squared. And then now these are the same, and that's negative 26, and then the plus 21. I think you can agree this one's definitely, this might definitely be one where you set the question equal to the answer, but make sure you store a value for x. Remember how I said when there's a pattern 2, 1, nothing, 2, 1, nothing, it makes it so the diagonals will be great. Well, if you look here, this has a pattern 2, 1, nothing, but this has a x squared and a y. So that means the pattern isn't going to be as nice as we like it. But if you look here, this is one group, 2 groups, and this is 1, 2, 3. So it's a 2 by 3. I mess with you a little bit by putting that y. And again, notice how I take up space here. Negative x squared y plus 2x, 3x squared, plus 2x minus 1. Multiply. I'm going to put a negative 1 right there for my sanity. Negative 1 times 3 is negative 3. I have 2 x's and 2 x's. That makes 4 x's and a y. Negative 2 times 1, negative 2, 2, 1, 3, and a y. Positive 1, x squared y. Now notice what the x's are doing though. 4, 3, 2. Because there was a pattern with the x's, 2, 1. So now I'm going to not do the top row. I'm going to focus on the bottom row. 3 times 2 is 6x cubed plus 4x squared minus 2x. So if you look, 3, 2, 1. Now remember how I said if there isn't a pattern in the problem, it's going to be hard to find the pattern in the answer. So if you look, these both have an x cubed, but that has a y, so they are not the same. Okay? So now just write it in standard form. So I'm going to go negative 3, x to the 4th y minus 2x cubed y plus x squared y, because none of these are the same, plus 6x cubed plus 4x squared minus 2x. Oops. Let's try one more. This last one is a 1, 2, 3 by 1, 2, 3, 4. I probably was a little bit obnoxious with my box, but it'll be okay. So negative 1x squared plus 9x plus 10, negative 1x to the 4th minus 2x squared plus 8x minus 1. Now, this has a pattern because it goes 2, 1, nothing. But this doesn't have a pattern because this is 4, 2, 1, nothing. So the diagonals aren't going to be cubed like we want that. So negative times a negative is a positive 1, x to the 6th, 2x to the 4th, minus 8x cubed, plus 1x squared. I'm just putting the 1 just to see. And then now notice what it does, though. It skips, right? Look at that pattern. It's like plus 2. 9 times negative 1 is negative 9x to the 5th, negative 18x cubed, positive 72x squared, negative 9x. 5, 3, 2, 1, 6, 4, 3, 2. See how it skips? Right here is where it skips because that skips there. And then now the last row, negative 10x to the 4th, minus 20x squared, plus 80x minus 10. Although the pattern isn't cute, like the diagonals don't match up, it's still nice because it's in boxes. So I have positive 1x to the 6th. And now I look to see, I have x to the 5th, nothing else. And I might cross it off because this has gotten a little bit messy. And now x to the 4th. So if I look, I have an x to the 4th here. I have an x to the 4th there. That'd be minus 8x to the 4th. Now notice I'm like kind of crossing it off because it's not set up for me. But there is kind of a pattern, isn't there? Kind of rises, but it's like off by 1. Okay, that's x cubed. So negative that is negative 26x cubed. Now let's look at x squared. Well, the x squared ended up lining up perfectly because if you remember, this got skipped, so it got kind of messy over there. So negative 20 plus 72 is 52, plus 1 is 53x. And then now my x's line up. 80 minus 9 is 71. Oops, squared. And then minus 10. Big answer. Definitely polynomial, degree 3, 1, 2, 3, 4, 5, 6, 7 terms. Okay? Your homework, and this is only the first part of multiplying polynomials, but I want to make sure you're clear. That will cover this K16. You should have already done this on Monday. I know we're off days a little bit. This was Friday, and this is Tuesday, Wednesday, so now we're good and we're back. Okay?